Relations and functions, go ahead and write down the definition. A relation is a set of pairs of input and output values. So basically it's a set of coordinates, x and y values. Input is the x, output is the y. And the first example, graph the relation. Here's a relation right here, set of points. -2, 4, 3, -2, -1, 0, and 1, 5. So you got to make sure that you remember how to plot points. What comes first in a coordinate? For -2, 4, what comes first? Yes? Which value?
Axis.
X. Just think about the alphabet. What comes first alphabetically? X or Y? X. So -2 would represent X, 4 would represent Y. X-axis is the horizontal axis, Y-axis is the vertical axis. So to plot these points, -2, 4, I just go left 2 and up 4 and plot that first point. 3, -2, go right 3, down 2. -1, 0 here, and 1, 5 would be here. All right, what quadrant, see if you remember this, what quadrant is -2, 4 in?
One.
Yeah, 1.
-2.
Oh, yeah.
-2, 4 is here.
Two.
That's quadrant 2. Okay, what about
Is 1?
1, 5?
That's quadrant 3.
That's quadrant one.
Quadrant 1.
Oh,
So it starts here and goes counterclockwise. 1, 2, 3, 4. So the point 3, -2 is in quadrant 4. Now what about the point -1, 0? It's not in a quadrant. So you would just say it's on the x-axis. Okay? So it doesn't have to lie in a quadrant, it can lie on the axis. Okay? All right, write this down. Two definitions, domain and range. The domain is your x values of a set of ordered pairs. And the range is the y values of a set of ordered pairs. So basically all we're looking for is the x and y values. List them out. List them out for domain, list them out for range. Example below, find domain and range. When you list it out, you don't repeat values. All right, you just list it once. So for the set of points, 2, 4, 3, 4.5, 4, 7.5, 5, 7, 6, 5, 6, 7.5. For my domain, all I do is, in order from least to greatest, list out the x values. So that's where I get 2, 3, 4, 5, and 6. I don't repeat the 6. There are 2 6s up here, but I only put 1 on. Okay? Same with range. List all your y values. We've got least to greatest, 4, 4.5, 5, 7, and there are 2 7.5s, but you can just put it once. Okay? Make sure you go from least to greatest for domain and range. Any question on that? All right, next example. Make a mapping diagram for the relation. So you're given 4 points. -1, -2, 3, 6, -5, -10, and 3, 2. D and R stands for domain and range. So you make a box for your domain, make a box for your range, and again, just like we did in the previous example, we're going to go from least to greatest. In the box, from top to bottom is least to greatest. So what is your smallest x value up here?
Negative 5.
-5, and what?
Negative
-1, and then 3 is repeated. You just list it once. And same thing for range. -10 comes first, it's the smallest. Then -2, +2, +6. Then you just draw an arrow from what's matching up with x and y. -5 pairs up with -10. -1 pairs up with -2. 3 pairs up with both 2 and 6. Okay. Go ahead and write that definition down. A function. A function is a relation, so it's a set of points. We already know what a relation is. It's a set of points in which each element of the domain is paired with exactly one element in the range. So each x value can only be paired up with one y value. I'll give you a second to write that down. All right, so your example below, I've got two different examples here. These are two different examples. You get a mapping diagram on the left and just a set of points on the right. Determine if the relation is a function. So here, if I give you a mapping diagram, if you have an arrow coming out, two different arrows coming out of the same x value, then it's not a function. Because you've got -2 paired up with -1 and +3. That can't happen in order for it to be a function. Now if you're given a set of points, all you do is look at the x value. Is the x value repeated at all? 3, is there another 3? Is there another 5? Is there another 4? Is there another 0? No. If that's the case, then it has to be a function. Alright? Now, if I did this, let's put this in here. What if I put 3, 9 in there? Then is it a function? No, it's not. Because 3 is paired up with both 6 and 9. What if I did this? Well, 3, 6. Is it a function?
Yeah, that's
Yes.
the same thing.
Yes, because it's the same point. Okay, that doesn't matter.
But if
All
they
right,
have,
still a function, yeah.
if they have two the same, would you write like both of them? Or would
No,
you just
just
write
write
like
one.
once? Alright.
Just once. All right, so going back, right here, is that a function?
No.
No.
In the previous example, it's not, because the 3 has 2 arrows coming out of it to 2 different numbers. All right? Now, another way to determine if something is a function, graphically, if it's a function, is the vertical line test. Vertical line test says if you can draw a vertical line anywhere through a curve or any graph, and it intersects that curve more than once, then it's not a function. The first one is a function, because there's nowhere I could draw a vertical line. This is vertical, right? If I just move that along, it doesn't intersect, there's no way it can intersect this curve more than once at any point. Okay? So just picture it. It's never intersecting more than one time. Over here, I can draw a vertical line in many different areas of this curve where it's intersecting twice. Therefore, it is not a function. So the vertical line test, if you're given a graph, you can pretty much look at it and tell. If it's a function. Okay?